So hello children. So up to the previous lecture we have discussed about the zero error in the vernier caliper. Zero error in the vernier caliper. That means zero error arises when the two jaws are brought together and the zero of the main scale and the zero of the vernier scale is not exactly coinciding. Not exactly coinciding. That means what? Either the vernier scale will be to the right of the main scale, the zero of the vernier scale will be to the right of the main scale, or it will go to the left of the main scale. So if that zero of the vernier scale is remaining to the right of the main scale, zero of the vernier scale is remaining to the right of the main scale, then we call it as a positive zero error. When zero of the vernier scale is on the right of the zero of the main scale, when jaws are in contact, then there is positive zero error. And when the jaws are in contact, zero is exactly coinciding, then there is no zero error. But if it is before that the zero of the vernier scale is before the zero of the main scale, then we are having the positive zero error, that is towards the right. So now to remove this zero error, this 0 0 is not coinciding, but some some lines of the vernier scale will exactly coincide with the lines on the main scale. Some lines will coincide, that lines we will see. Suppose it is sixth line, as per your book it is given, sixth line is coinciding, and that we will multiply with the least count. So that will give us positive zero error. So 6 into least count is 0.1 millimeter, or we can say 0.01 centimeter. So we will get 0.6 millimeter or 0.06 centimeter. So this is the positive zero error. So this zero error has to be subtracted from the actual reading. What is actual reading? That is main scale reading plus number of divisions coincident into least count. What we have taken the reading without considering the zero error, from that one we have to subtract this one. Next one, opposite to that of negative zero error, when the jaws are brought in contact and the zero of the vernier scale is on the left side, zero on the vernier scale is on the left side, then we call it as a negative zero error. Then how we will remove this negative zero error? That is not exactly same. Here we will take one bracket and we will take minus sign outside that bracket. We will take minus sign outside that bracket, and number of divisions on the vernier scale, that is 10. So we will take 10 minus, now we will follow the same procedure. Which division is coincident? If 0 is not coinciding, some divisions will be coinciding. Suppose here it is taken 4, it may be 3, it may be 2, it may be 1, anything it may be. So minus 10 minus 4 into least count. Okay, so 10 minus 4 we are getting minus 6 into 0.1 millimeter. So we will get the answer negative zero error, we will get it with negative sign. So here this also we have to subtract from the actual reading. But what it will be? It will be added to that actual reading. It will be added, because minus minus it will become plus. So when we are getting the negative zero error, then it is added to the actual reading. And when we are getting the positive zero error, then it is subtracted from the actual reading. Okay. So correct observation after considering zero error. Correct value equals to observed value minus plus minus zero error. Plus minus, concept of plus minus you have understood. If it is positive zero error, then directly you will subtract. Okay, because it will come with plus sign. If it is negative zero error, it will come with negative sign. It will give us minus minus, it will give us plus. So it will be added. It will be added to the value which we have got. Now procedure. So these procedures you can read it, that same as we have discussed. So that procedure we will follow in the lab to take the readings. So least count of the vernier scale we are knowing. So just you see, main scale reading plus vernier scale division, then we are getting the reading vernier scale division coincident into least count. So main scale reading plus, you see the first, after serial number, this is main scale readings. This main scale reading MSR, and afterwards you see this B VSR vernier scale division, that is coincident into least count. Okay. So Observed value is A plus B. So the formula is, as I have told you, main scale reading plus number of division coincidence, that is vernier division coincident with the main scale, into least count. So we will get one value, then again we will take by just keeping the object at some other position. So we can take 3 readings, 4 readings, and we can take the mean of that reading. So we will get the more precise readings. Okay. So in this way we are taking 4, 5 readings. So next one, screw gauge. Screw gauge is also based on the same concept. So it is an instrument by which very small objects like diameter of a wire can be determined up to an accuracy of 0.01 millimeter, or we can say 0.001 centimeter. Okay, 0.001 centimeter. Here it is given millimeter, it is not millimeter, it is centimeter. Okay, that is 1/1000 in case of a screw gauge. So here one specific terms comes, the new terms will come, that is pitch. What is pitch actually? So first you understand what is pitch. So all of you have seen the screwdriver, screw. When you are just tightening the screw with the screwdriver, then that screw is going inside. If you are loosening that screw, then that screw is coming upside. So if you are tightening the screw, then suppose you are giving one complete turn of 360 degree to the screwdriver. पूरा घुमा दिया 0 से लेके 360 डिग्री तक, means you are giving one complete rotation to the screwdriver. Then the screw will move inside, little bit it will move inside. That distance is a linear distance. So whenever a circular scale is given one complete rotation, that is 360 degree, it will move on the linear scale, that is on the main scale. So that linear distance which is moved on the main scale, that is known as the pitch of the screw. Now we have discussed in terms of screw, simple screw which we are tightening or loosening. Suppose we are tightening it once completely, we are rotating, complete rotation of 360 degree we are giving, then the linear distance which that screw is moving inside the wall or wherever you are tightening, that linear distance is known as the pitch of the screw. Here we will talk about the screw gauge. If its construction, you will see, instead of the main scale and the vernier scale, it is having the main scale and the circular scale. So main scale and the circular scale. So if you are just, circular scale is having total number of divisions 100 generally, which we are having inside the lab. That screw gauge is having 100 divisions. Okay, so if you are giving one complete rotation to the circular scale, then it will cover some distance on the main scale. That distance coverage is known as the pitch of that screw gauge. So this is the new term that we have studied here. So it works on the principle of screw. The linear distance which the screw moves in one round is equal to the distance between two consecutive threads on it. That is, the distance is called the pitch of the screw. Generally the pitch of the screw is 1 millimeter or 0.5 millimeter. So generally we are taking it as 1 millimeter. So now you see the basic construction of this one. 2 points are there, A and B. One stud is there. We are keeping the object in between these 2 points, A and B. One main scale is there, and one circular scale is there. And circular scale is having 100 divisions, suppose we have taken. Generally it is 100 divisions. One hollow cylinder is there, one ratchet is there. So circular scale, basically you have to focus on circular scale and main scale. So circular scale, if you are just turning once to 360 degree, then it will move on the main scale some distance. That distance is known as the pitch of that screw. Okay. So from that pitch, we can determine the least count of the screw gauge. So least count of the screw gauge equals to pitch of the screw divided by total number of divisions on the circular scale. So pitch we are taking 1, suppose. So 1/100. So 1/100 means 0.01 millimeter. So 0.01 millimeter, or we can write 0.001 centimeter. Okay. So its construction I am not reading. Just construction you can read it. It is very simple. Okay. So the pitch is 1 millimeter. and divisions on the circular scale are 100, then the least count will be 0.01 millimeter. If we will change it, then the least count will also change. Okay, now it is also having the zero error, like as we were having the zero error in the vernier caliper. So vernier caliper, the zero error we have specified by saying that whether the zero of the vernier is before, that means towards the right of the main scale, or towards the left of the main scale. If it is towards the right of the main scale, then we have taken positive zero scale. If it is towards the left of the main scale 0, then we have taken as the negative zero error. Here we will take up or down. Here we will take up or down from the baseline. Main scale reading we are considering, it is written as baseline. So main scale reading 0. If the 0 is going up, when the stud A and B are made in contact by rotating circular scale, and 0 of the circular scale is below to the baseline. So first we will see below only. When that 0 is below the baseline of the main scale, then we will call it as the positive zero error. And if it is upper side of the baseline, then it is having the negative zero error. So these things you have to remember. That is, if the 0 of the circular scale is below to the baseline of the main scale, below, then we are considering below to the main scale, then we are considering positive zero error. If it is above the baseline, then we are considering it is the negative zero error. And its removal and other things are same. Positive zero error means if 0 is not coinciding, it is going below the main scale, then some points will be coinciding from the circular scale. Suppose here as given, it is third point is coinciding, third division is coinciding. So third division is coinciding, so that means positive 0 equals to number of division coincident into least count. So 3 into 0.01, that means 0.03 millimeter. So we got positive zero error. So simply we will subtract from the actual reading. So how we will get the actual reading? Main scale reading plus number of circular division coincident into least count. वैसे ही जैसे उसमें लिए थे. Number of circular scale division coincident into least count. There we were talking about number of vernier division coincident with the main scale into least count. But here we are talking about number of circular division coincident into least count. If two studs we are bringing together without keeping any object, if these two studs we are bringing, A and B parts we are bringing together, and 0 of the main scale is exactly coinciding with the 0 of the circular scale, then there is no zero error. Then no need to determine this positive or negative zero error. But if it is coming below or above, then we have to remove and we have to rectify that one. Okay. Next one is negative zero error. Same way, negative zero error, we will take it with negative sign. So we will subtract the number of divisions coincident. That is, suppose the total divisions on the circular scale is 100 and division coincident is 98 in case of negative zero error, when the 0 is going above the baseline. So 100 minus 98 into least count. So it will be 100 minus 98 minus 2. So we will take it with negative sign, that is minus. Outside the bracket we will take negative sign, 100 minus 98 into least count. So we will get 2, that is minus 2 into 0.01. So we have got the negative zero error as minus 0.2. Now correct value equals to observed value minus plus minus zero error. So if it is positive zero error, it will be subtracted. If it is negative zero error, it will be added, because minus and minus will become plus. Now procedure, there is no need of procedure. So main scale reading MSR plus circular scale, that is coincident, into least count. These two we will add together and we will get the observed value. So we will take at different positions. We can take 3 readings, 4 readings. Here it is given only 3 readings. We can take 4 also, we can take 5 also. So these readings we can take, and we can take the approximate of these values. Okay, mean of these values. And the next one is backlash error. Some error is committed due to wear and tear. The gap between the thread increases on reversing the direction of rotation of the circular scale. The tip of the screw does not move at once and remains stationary for a part of rotation, called the backlash error. This is known as the backlash error. Okay. Now in order to avoid or minimize this error, the screw should be rotated only in one direction. If it is required to change the direction, do not change at once. Move the screw further, stop there for a while and then rotate it in the reverse direction. So due to this rough handling, we are getting this backlash error. So now these topics are over. So now our next topic in this chapter will be simple pendulum. So that one we will start in the next lecture. So now we are stopping, dear children. So thank you.